There are different ways of dealing with treatment heterogeneity. The simplest strategy is to simply ignore it. That obviously has its consequences, as I will explain in this clip. An alternative strategy is to collect your data after you have conducted your experiment and then see whether you find any meaningful treatment heterogeneity. And in that case, you use treatment by covariate interactions. A last strategy is to think about treatment heterogeneity before conducting your experiment. And in that case, you are going to use a so-called factorial design of your RCT, and then after the data come in, you can also use this treatment by covariate interactions to test for the presence of treatment heterogeneity. Alright, so say now that we ignore it, so we stay with what we learned in Econometrics 1. So we simply report the average treatment effect. Well, you should realize that what you report then is basically the weighted average of the treatment effect across subgroups. So what does it mean? Let's apply that to Alcott 2011. Say that we look at the treatment effect for two subgroups. There's the efficient households that already had a low electricity use before the treatment. The effect for them is denoted by alpha 1 prime. And then there's the treatment effect for the not so efficient households. And their treatment effect is denoted by alpha 1 double prime. Now, if both of these groups are similarly large in your data, then the average treatment effect is the weighted average of those two for those two groups. So how does that work? It's 0.5, so 50% for one group times the treatment effect for the efficient households plus 0.5 times the treatment effect for the not so efficient households. Well, we know that the effect for the efficient households is 0. There's no effect. So that basically means that we can set that to 0. So alpha 1 prime is going to be 0. So the average treatment effect is then basically half the treatment effect of for the non-efficient households. Given that Alcott on page 1087 reports an average treatment effect of minus 2%, then based on this simple calculation and assuming that both groups are similarly large, we can conclude that the effect for the non-efficient households is actually minus 4%, so twice as large. Say that we will only report this average treatment effect. What consequences would it have? Well, first of all, and that's something that I alluded to earlier, that we may well conclude that this treatment does not have much of an effect, and then actually decide not to adopt it, either as a business or as some government agency, foregoing any benefits that the treatment has for specific subgroups. So basically, it may lead to false negatives. Secondly, if we know that the treatment only works or is most effective for a certain subgroup, then it makes sense to focus the treatment on that subgroup, right? So it allows targeting and it gives us a greater bang for the buck. Finally, if we see that the treatment does have an effect on certain groups but not on other groups, or much less on other groups, that gives us also an idea of what is behind the treatment effect. So what are the mechanisms behind this? This is actually something that we will explore in more detail in the third week of this course with the topic mechanisms.